Moving on from objective 2, in objective 3 we are still going to be rationalizing denominators. So we are going to be making sure that there are no radicals or irrational numbers in our denominators. But this time our denominators are going to be binomials, meaning there's going to be two terms in the denominator. So before we go into how to rationalize a denominator, I just want to remind you what happens when you multiply two complement or conjugate brackets together. So this textbook calls these conjugates, where they're the identical brackets, but one has a plus and one has a minus. Other textbooks will call these complements of each other, but in reality, what I want you to notice is that when you multiply two identical brackets together, where one has a plus and one has a minus, something happens. So if I multiply 4 times 4, I get 16, and then I keep distributing. I get 4 times negative root 5 is negative 4 root 5, and then root 5 times 4 is plus 4 root 5, and then root 5 times negative root 5 is negative root 25, or maybe you recognize that when something multiplies by itself, so a radical by itself, you end up with just 5. But whatever you do, you get here. And because those brackets were the same with different signs, your middle terms will always cancel out, and you'll be left with 16 minus 5, which is 11. So what happened is that the radical goes away, or is cleared, or whatever terms you want to put in here. But what I want you to notice is that when you multiply two brackets together that are the same except for the signs, because you're squaring the first number and you're squaring the last number, and the middle terms go away, you're going to get rid of the radicals. So the first thing I want to practice is just finding conjugates. So the conjugate of root 6 minus 2 root 3 would be root 6 plus 2 root 3. So different signs, same brackets. When you multiply this out, you'll go first times first, so you'll get root 36. And then you can keep distributing. So root 6 is 1 root 6 times 2 root 3 would be plus 2 root 18. And then when we do the next one, we get negative 2 times 1 is negative 2 root 18. These will cancel out. And then we get negative 2 times positive 2 is negative 4, and root 3 times root 3 is root 9. The moral of the story is you're going to end up with perfect squares as your first and your last, and that middle terms are going to go away. So you're going to have 6 minus 12, which is negative 6. So try this one. So pause the video, find the conjugate, and multiply through. So for this one, the conjugate will be 2 minus 3 root 5. When we multiply through, you're going to do your first times your first, which is 4. Now you don't have to do the outers and the inners if you don't want, because if you know they're going to cancel out. If that's too much of a jump for you, feel free to. So 2 times negative 3 root 5 is negative 6 root 5, and then this one should be positive 6 root 5, so you can leave those out if you want. And then the important thing is that your lasts here are going to be positive 3 times negative 3 is negative 9, and then root 5 times root 5 is 5, or you can put root 25, you can put in a step, whatever works for you. So this is going to be 4 minus 9 times 5, which is 45, and so it's going to be negative 41. But the key thing is that when you multiplied the conjugates together, you got rid of, or you cleared, the radical. So we can now use conjugates to rationalize binomial denominators. So we are never going to be rationalizing trinomial denominators. This is as far as we go. So how do we do it? Well, we want to get rid of the radical in the denominator, so we multiply by the radical in the denominator, or the conjugate of. So if the denominator is 2 plus root 6, the conjugate is 2 minus root 6. You're only allowed to do this if what you multiply the bottom by, you also multiply the top by. Now I'm going to recommend that you don't actually distribute the 4 through, meaning you write it as 4 times 2 minus root 6, because when you rationalize your denominator, often this ends up as a number that will simplify if it's in factored form. So in the denominator, I get 2 times 2 is 4. You can write the middle terms if you want, or you can leave them out. I'll write them to be safe for a while. So minus 2 root 6 plus 2 root 6, right? Outers and inners. And then my last are going to be plus root 6 times negative root 6, so negative 6 or negative root 36, whatever you're seeing to write. So we've got 4 times 2 minus root 6 on the top, and on the bottom, the outers and inners are going to cancel each other out, and I'll be left with 4 minus 6, which is negative 2. Now, because I left this in factored form, I can simplify the 4 factor, so 4 divided by negative 2 is negative 2, and I'm left with negative 2 times 2 minus root 6. And just like in chapter 6, this is a fine answer, or you can multiply through if you want and get negative 4 plus 2 root 6. You should be able to recognize it either way. And now I've got 2 more examples here to work through, but there's nothing different. So if you want to pause the video right now and try these 2, feel free. Because we're just going to repeat this process 2 more times. So we are going to multiply by the radical in the denominator, or not the radical, but the conjugate. So if we have root 2 plus root 13, we're going to multiply by root 2 minus root 13, top and bottom. Don't multiply the top through, keep it as 7 times root 2 minus root 13, and then FOIL through your bottom. Root 2 times root 2 is root 4, or just 2. And then keep going. Root 2 times negative root 13 is negative root 26. And then I'm going to get that plus root 26. And then my last, I get square root of 13 squared, which is what, 169? Okay, but we get 7 times root 2 minus root 13 all over. Your outers and your inners cancel out. We're left with 2. Oops, sorry, don't do what I just did. Don't put a plus. This is never going to be plus. As soon as I saw that, I was like, ooh, I made a mistake. Every time you're multiplying conjugates together, this last term will be negative, so be careful. So this is 2 minus 13, which works out to 7 times root 2 minus root 13 all over negative 11. Now, this is an okay answer. I can't simplify the 7 and the 11 at all. I say okay because I'm not a huge fan of this negative sign here. Okay, so what I would recommend doing is actually moving the negative sign up. So I would write negative 7 times root 2 minus root 13 all over 11, or you could write it as a negative out front. Did you notice that I figured out finally how to change colors? I could put the negative out front, and then I could do 7 times root 2 minus root 13 all over 11. So all of these answers are valid. It's just where you put the negative sign. My least favorite is the one where the negative is in the denominator. All right. Last one, so again, maybe you're ready to give these a go now. I'm going to multiply by the conjugate. So in the denominator, I have 3 root 5 minus 1. So the conjugate is 3 root 5 plus 1. I'm going to multiply top and bottom by the same thing, because then I'm multiplying by 1 and not changing the value of my expression. I'm not going to multiply that 2 through. I'm going to leave it out front. And then I'm going to do the bottom. So I've got 3 root 5 times 3 root 5 is 9 times 5, or 9 times root 25. Whatever maybe I should change it up a bit. So if this was my work, when I do these, I go 3 times 3 is 9. Root 5 times root 5 is root 5 squared, or just 5, just to do something different. And then I know that my outers and my inners are going to cancel out, so I don't write them down. And then I've got negative 1 times 1 is minus 1. So then I've got 2 times 3 root 5 plus 1 all over 45 minus 1 is 44. And then always check to see if you can simplify. You should notice that 2 goes into both 2 and 44. So this is going to go to a 1 and to a 22. So that my final answer is 3 root 5 plus 1 all over 22. All right, go give those a go. So this is rationalizing binomial denominators.